So this was the question at the end of the previous video. There are four reservations, and we are looking for the probability that exactly two reservations are canceled, which means two are canceled and the other two are not. Two success, two failures, right? And then the last part can be the probability of a single outcome can be calculated easily. So multiply the probability of success two times and more probability of failures two times, right? So zero point 0.1 should be multiplied twice and zero point 0.9 multiplied twice. And then in the end, it's 0.81%. So this is probability of a single outcome. But you have to calculate how many possible outcomes there are. How many outcomes are included in your event, y equals to 2. So we have to count the total possible outcomes included in this event, and it is not easy. So we are going to list all the possible outcomes first. It is not easy when you have four reservations. So when you have two, there are four outcomes, four possible outcomes, and when there were three reservations, there were eight possible outcomes. But when you have four reservations, it becomes 16. So when you have one more reservations, you get the total number of outcomes uh, increases by like doubles. The number of possible outcomes doubles for each reservation. So it quickly becomes extremely huge. Anyhow, so far yet we can write down all possible outcomes like this. It's all possible combinations. 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, like this. 1, 1, 1, 1, and the final one. And among these 16 combinations, you may try this by yourself if you cannot believe. Try to find one that's not included in here. We have to find the outcomes where only two reservations are canceled. Two reservations are canceled are those guys. Those six guys. What's surprising here is you may have expected there would be four or like something related to four, but actually the number is six. Where did the number come from? Six is two times three, but there is no three in the question. So in the end, the answer is if you believe it is, if you understand it is six, there are six outcomes, then the answer, the final probability of two cancellations can be calculated this way. There are six different outcomes, and each of them has this much probability. So if you calculate that, the answer is 4.86%. Then the real problem is why? Why is it 6? It suddenly does not satisfy our previous pattern. Like for example, what I'm saying here is 2, 3. Then you may have expected 4 here, but it was not. It was not 4. So then how can we understand this? Here is the general rule. So let me admit this. Actually, I try to, so I try my best at each topic. I try my best to explain how we derive that result and what is the intuition behind it. And I'll try to give you like examples and simplify the theory, but I think I cannot do this for this topic. The combination rule is a mathematical rule that's a general formula to calculate this part. I can explain this if you give me like on another week, but it's relatively less important than the other guys, and takes too much time, and I'm not confident if I can do that. So I will just put this rule as a rule. So this must be, I believe, this is the only formula that I uh, ask you to memorize. So I I do not have good intuition for this. So let me let's have a look. So we define another mathematical notation, n factorial. So n exclamation mark here is a mathematical notation. It stands for the multiplication of consecutive numbers from n to down to 1. So n factorial is the multiplication from n down to 1. So multiply all the integers, all the natural numbers. So it's called n factorial. And the number of possible combinations when you choose y out of n will be denoted in this way, which we read as n choose y. So n combination y or n choose y. So different textbooks use different notation. And when I read it on Wikipedia, I learned that different countries use different notation. So I'm from South Korea, and I learned it in high school, and the notation was different. At that time, we used N, C, Y, something like that. But in the United States, this seems standard, so I will use this notation. But it doesn't matter, like just even though notation can be different, the formula should be the same, right? If you learned in different ways, then you can think that way. Just you are right. What you learned is not wrong. So anyhow, then the combination rule. This is the formula you need to use. N chooses y equals this, n factorial divided by y factorial times n minus y factorial. So it's so annoying. So let me put it like so. If you ask me what does it mean? So this is exactly what we wanted. Like say there are 4 reservations and we have 2 cancellations. Then what we are doing is we have to count what kind of combinations of 2 reservations are possible. So you are choosing 2 reservations out of 4. Then n equals 4 and y equals to 2. So number of possible combinations when you choose 2 out of 4, right? Then to answer that, you have to apply 4 and 2, 4, 2 here. This is, it's very unnatural, a counterintuitive formula. So hard to explain where it's from. But special case is obvious. Some special case. If you choose nothing, there is only one possible case. So if there is no cancellation, that's the only possible case. There is no different scenarios. So everybody not canceled. Or if every reservation is canceled, then that's also only one possible scenario, because there is no switch on and off. Like everyone has to cancel. That's it. So these 2 cases are simply 1. And I'm telling you this because if you have 0 or n, denominator has to calculate 0 factorial, which requires more complicated discussion. So, however, the result can be understood more naturally. And here is more examples. Where can we use this rule? This rule is maybe the most interesting, most popular example to apply this rule is to playing cards. right? So for example, suppose that you get 5 cards from 52 cards. How many combinations possible? So then applying this rule, we can write this answer in this way. This is the number of possible combinations in a card game. So, and I'll tell you one pattern. So in this case, in the denominator, you multiply number from 5 down to 1. This number, take this number and start from that number and multiply down to 1. And in the numerator, also start from this 52 and multiply consecutive multiplication up to this many numbers. So you are multiplying 5 numbers, 1, 2, 3, 4, 5, starting from 52 and down to 48. So you are multiplying same number of numbers in the numerator and the denominator, but their starting points are different. Starting points are given by these two guys, right? And another example, suppose that you choose 2 toppings out of 10 options. Say when you order a pizza or salad, you can choose toppings, suppose 2 toppings. How many combinations possible? Different combinations possible? The answer is you will be multiplying 2 numbers in both in denominator and numerator, and denominator starts from 2 and numerator starts from 10. So multiply, multiply. This is how you calculate this. Okay, then try to apply the combination rule and calculate of 5 reservations, 3 are cancelled. And then in this case, it's even more general than what we considered earlier. Then how many combinations are possible, right? I'm going to answer this question in the next video. So try to apply this rule, or like write down something like multiplication like this. So three numbers should be multiplied in the numerator and the denominator. So try to answer this question. You may use a calculator, of course, right? See you. Bye.